In this video, we will look at under one condition we want to use the higher order regression, higher order regression model to analyze our data, especially the second order regression equation. So before we start to look at this example, let me review when we should consider to use the higher order regression equation. So that's related to the relationship between the function and the graph. So if we see the curvature, the curve look like what you are seeing in the screen, and then we will consider to include the second order into our function when we build out the model. So before this chapter, we usually use the linear function because we think the linear line is the best line to capture the characteristic of those observations. However, in some cases, after you do the scatter plot, you can very easy to identify the curve in the plot. So at that scenario, you need to consider to use the higher order in your function. So for this example, we are looking at the car price. So what will affect a classic car's price? So for people collect the data, you're considering the year of the car, the make of the car, the model of the car, and also the rating of this car. So for this practice, we especially to study the relationship between the rating of the car and the car price. So we only consider column D and column E. So as I mentioned, before you impose the linear relationship into the model, you need to consider, do you need to include the higher order of your explanatory variable into the model? So you need to create the scatter plot. So in order to create a scatter plot, you choose Insert, find the scatter, choose the basic one. Then we can select our data set, select data, and add. So in this question, the y variable, dependent variable, would be the car price, which is our column E, and the x explanatory variable is the rating of the car, which is column D. So now we can choose the x value. So the x value is from D2 to D16, so we totally have 15 observations. And now we can choose the y value, which is from E2 to E16. And after you finish selecting the dataset, and you can click OK. So here is the scatter plot, car price versus the rating of the car. So you can find a very significant curvature here. So now you should consider why not include the second order into our model. So now you want to ask why not third order, just to second order. So if you go back to look at this slide, you will find the second order will make the curve look like look like this. If you include the third order into the model, and you will see the curve start to change the direction, so which is not you can see in our scatter plot. So the best model we should do is we will include the second order of our explanatory variable into our model. So now first let's copy the dataset to a new worksheet. And then, make sure you know what they are. So the rating is our x, and the price is our y. And we are thinking to include the second order into our model for x. So let's insert one column for our x. So now we are creating a variable called x squared because we want to include the second order of x into our model. So now you want to ask me, how can I get the observation for x squared? So actually it's very easy. So you just square every observation of your x. So that's equal to, and b2 powered by 2. So that is the first observation for x squared. Then you are using the powerful function on Excel to do the same thing for the rest of the observation. So now we can start to do the regression analysis. Click data, data analysis, regression. And so our y variable is the column C, and our x variable is from column A to column B. Don't forget check the label, and you can check the rest of the box to do the diagnostics. Name it as regression. And keep 4 decimal places. So we are really interested in our p-values. So now here is a surprise. Both x and x squared are significant. So it's right for us to include the x squared into our model. And so if you look at R squared here is 70.23% of variation in our x is explained by our y variable. So now compare this model with our original regression model. So let's do another analysis. So if we only include x as our explanatory variable, so insert data analysis, regression. So we will only include the column B. So we want to compare how it looks like. What's the difference? So format cell number 234. So now let's look at just our R squared here. So compare the just regular simple linear regression model with the regression model we included a higher order x squared, and we can see both R and R squared get improved by including the second order. So before, if we only look at the simple linear regression model, and we found 44.39% of variation in x is in y in the car price explained by the rating. After we include our x squared, and we can find our adjusted R squared increased. So that is 65.27% of variation in car price can be explained by a regression model. So based on this result, we can conclude that our model get improved by including the second order. So again, if you want to include the second order of your explanatory variable, you need to look at your scatter plot first. If you see the significant curvature in the scatter plot, you should include the higher order into your model.